Sir?
We just have to write a formula, we don't have to know how to get it through.
Right, you will never be asked to derive them. I think it's important for me to explain how you derive them. And I think the arc length one's good to see it because you see how the Pythagorean theorem is where that square root comes from. Otherwise, it seems really random why there'd be a square root that gives you arc length. But when I explain it with Pythagorean theorem, you're like, okay, that makes a little bit of sense. At least I hope it does. All right, good. I'm glad Jordan does for Jordan. All right, so with the surface area, same idea. You take some curve from A to B, and we're going to rotate it around the x-axis. All right, so it looks sort of like that. Yeah, close enough. And when we rotate it around, we get, this shape. Oops. Alright, so obviously that's not perfectly symmetric, but you guys get the idea. So this curve gets rotated on the x-axis. And what we've already talked about is we can find the volume of this figure by doing what? Which method would we use? Disk method, right? We're sliding these disks from A to B. And that creates the volume of our of this thing, this object, this figure. So now what we want to do is to find the lateral surface area. I don't care about the surface area on the sides, right? Just around. So we talked about to create that volume, we slide area. So to create area, what do you think we have to slide? A line, the other way around, right? So to find volume, you slide your area. To find area, you slide a line. So like a rectangle is base times height is equal to the area. So you take the line, the base line, and you slide it by the height. And that gives you your area. Does that make sense? That's where all our geometry formulas are coming from. Okay, so I want, which line am I going to be sliding here? That's not what we're going to think about it, though. We're going to think about the circle sliding. The circumference line. Yeah. The circumference is the line that we're going to slide here. And the circumference will then, paint the surface area of this figure. You guys see that? So you see this circle? And we're going to add up all these circumference lines.
That's crazy.
We're good.
All right?
Yep.
Very good. Okay, so the integral. What does the sliding? Yeah, but how do we symbolize we're going to slide something? The integral symbol. Stay focused, guys. I know it's Friday. All right. So we're going to integrate from A to B, and we're going to integrate the circumference. What's the formula for circumference? 2 pi r, but this radius is really the height of our function, which we'll call y. So it's going to be 2 pi y. Right? And now y will be in terms of x. It's some function in terms of x. And it's going to be a dy integral. And here's the part where a lot of people make a mistake in terms of thinking about this. This circumference is sliding from A to B. But the length in which it slides is not B minus A. It's not this. It's not sliding. It's sliding from A to B. That's true. But the length in which that line is sliding is longer than the distance from A to B. Well, how's it sliding? The arc length. Exactly. So the length in which this. So think about the point of the circumference. The distance that this point travels is not the distance from A to B, like in a straight line along the x-axis. It's really the distance along the curve. Does that make sense? Sort of? So that's the idea here. So the arc length formula comes in. You're left with 1 plus dy dx quantity squared. And this is why I show you the surface area formula. Actually, equals surface area. Surface area. But I like teaching surface area right after arc length because they're so closely related. Alright, yeah, question?
Isn't that square root of 1 plus dy of dx squared, isn't that a dx integral?
Oh, shoot, yeah, did I write dy? Yeah, the whole thing is dx. I'm sorry. Right, thank you. Yeah, because y is in terms of x.
Okay.
Yeah, and I think I said that y is in terms of x, but I wrote the wrong thing. Good catch. Alright, that's exactly right. Okay, so this is the surface area for me. On your AP exam, alright, surface area is actually not taught in most Calc 1 or Calc 2 classes. I don't know why. But in the classes I've encountered, they just skipped. Arc length will not be on your AP exam. It is on the Calc 2 exam. Alright? But it's not on the Calc 1 AB exam, so you can not have to stress about it for Cinco de Mayo when you're taking the AP test. However, it will be on our test. Okay, so you need to know it for me, for my class. Because it's so closely related to discs, shells, washers, I just package it all together. In next year, when everyone takes Calc 2, whether it be here or in college, you'll see it and it'll be like, ah, no big deal, I already did this. Okay? Good deal. Alright, thank you, CR.